Yeah. Hello, students. Good evening. How are you all? And students who are joining from YouTube Live, good evening. I hope you had your Mastwali chai. Yeah. And you're fresh to listen to today's class. Yeah. Aniket, good evening. How are you? So we'll be starting the session at 6:45. So until then, if you have any doubt, you can ask the doubt. In the meantime, yeah, we can have a chit chat. So students from JNV Bagalkot, good evening. Good evening, Abhay. Good evening, students from JNV Ballari. Okay, in the meantime, as people are joining and students are joining, so I'm going to check my technical, let's say, issues and all. So let me know, is my audio is clear? Is it perfectly clear? And is my presentation is perfectly visible or not? So I'm launching the technical check. So I'm launching the technical check. Let me know, students, through the technical check. Yeah, Abhay and Janvi Ballari students, good evening. Very good evening. So let me know, okay? Okay, great. So others who have joined now, please answer the technical check, okay? So Janvi North Canada students, good evening. All is well. Also, thank you. Thanks a lot, Abhay. Aishi, good evening. Okay, students who are there in the chat, let me know, is my audio and is my video clear or not? Okay. So as I can see, most of you have answered and there is no issue in my, let's say, audio and video, that is presentation. Okay, okay, thank you. Thanks a lot. Thank you, Abhay. Okay. So let us wait for 1 minute more so that other students join. In the meantime, if you have any doubt, you can ask. And if you want to have a nice little chat for 30 seconds, you can have. Let's say everyone had the tea also, right? Evening snacks. And I guess students from JNV or JNV, Ballari, Bagalkot, North Canada and all, they were having classes, right? So I hope you guys are with the nice, let's say, Josh itself. ಸುಸ್ತಾಗ್ಲಿಲ್ಲಲ್ಲ ಯಾರಿಗೂ ಸಹ ಸ್ಟೂಡೆಂಟ್ಸ್ ಯಾರಿಗೂ ಸುಸ್ತಾಗಿದಾ ಓಕೆ Shweta and Sushma, please join using the audio itself because you won't be able to listen to my class. Okay. Okay. So this time is up. It's 6:45 now. Okay. So students, Aniket, I am from a place called Puttur, which is in Dakshin Kannada. Let's say you know Mangalore, right? So welcome again for today's session, students. My name is Samanvit, and I'm your physics faculty in Avanti. Yes. So we are going to talk about what we were talking about. We were talking about Newton's laws of motion. Yes, Newton's laws of motion. Aniket, this is fine now. You got to know where I'm from. Yes. Okay. So we were talking about Newton's laws of motion, students. Is it good? So in that we have studied a lot of things. Let's say from the past 2 days class. Wait, thank you. Thanks a lot. Okay. So continuing that, now let us quickly go to the content of today's session. Okay. See, you need to know what we are going to study. Parth, good evening. So you need to know what we are going to study today. So Sweetie, good evening. Yeah. So the first thing is recall. Okay, we'll quickly recall what we have studied in the last class. Okay, if you have any doubt during that quick recall, let me know in the chat. Then today, Sushma, good evening. Yes. Okay, everyone has joined in the audio also. Nice. And what we'll talk about something called free body diagram. Okay, this free body diagram is required to solve numericals. Okay, to solve numericals, I'll tell you how to draw the what free body diagram. We call it FBD2. In short form, you can call it FBD. Okay, so no need to write a free body diagram, you can write it as FBD. Then we'll talk about what, let's say, how to draw FBD. Then we'll talk about concept of equilibrium. On basis of concept of equilibrium, okay, there is a numerical. Okay, numerical. So equilibrium के ऊपर एक numerical है. So based on that, we'll solve it. Okay, I'll give you time to solve it. Then I'll let's say solve along with you. Then what? At last, or not the least, at least we'll talk about the summary of today's class, so that you get the gist of the today's class. Students, so if that is the case, are you ready for today's session? Let me know in the chat. Let's say a thumbs up, or let's say yes or no. Anything is fine. If you're no, no. Okay, good, nice. Others. Okay, sweetie, nice. Abhay, nice. Parth, nice. Others, okay. Yes, sir. Oh, crazy. Good. Okay, coming into quick recall. Do you remember what we were studying in the last class? Do you remember? I hope you remember what we were studying in the last class. We talked about what? Tension, yes or no? It was not the tension of the exam tension. We were talking about tension in what? Physics, basically. Yes, very good. So what was the definition of tension? The force exerted by the end of a string, rope, or a chain against the pulling force is called tension. Yes or no? And the direction of tension is so as to the pull of the body. Yes or no? Let's say, see, we have seen the example yesterday also, but I'm giving an example. Like I'm going to explain it again. So if you have a body over here with a mass m, you know that the weight acts what? Weight acts downwards, vertically downwards. Now I said that this tension force that is going to act over here will always be what away from the point of consideration. So I said, for the trick, like how do you consider the tension? You need to consider tension always acts away from the point of consideration. Yes, let's say if I'm considering this point, then it will be always what? T over here. And let's say if I'm considering from this point, and here is the tension T over here. Yes or no? See, over here, always remember, if you're confused about the direction of the tension, after drawing the tension in the complete body, students, check whether it appears as if it's what? It is trying to reduce the length of the string. Over here, it is like appearing, right? It is appearing as if what? It is trying to reduce the length of the string. Yes or no? And also I told you that if it is same string, what will happen? Students, let me know. If it is same string, what will happen to tension? If the string is same, let me know, students, what will happen to the tension? Quickly, let me know. Let's say I have a same string, one string at all. So tension will be okay. Krishna, sweetie, very good. Others. No, I'm talking about if Abhay, I'm talking, let's say, if this is a string, so what will if the string along these 2 points? Let's say this is 1 point and this is another point, and I told you this is the what? Tension. So will it be T1 and T2, or T1 and T1 itself? What will it be? Or let's say T. Yes, T also same. Very good. North Carolina students. Yes, what will happen if the string is same? The tension is also same. Why this is same? Because we take yes, Abhay. So why we take the string as to be what? Massless. It should be massless. And second one is what? Second one is what, students? It is massless and what? Frictionless. Yes or no? Yes, very good. Krishna, very good. Yeah. So these were the points that we discussed about what? Tension over here. Yes. See, over here, that is the same thing. There was important points regarding, this is the important points. Okay. So don't forget this point. What is that? The first point is tension remains same if the string is same. Over here, let's say we had a pulley over here and there was a string. Yes or no? In the yesterday's example, I told you that there is mass. Okay. This will be T and the tension over here would be Gargadi, yes, T2. Yes, yes. This is called what? Gargadi in Gujarat. This is Gujarati, okay? Okay, Gujarati. So Gujarati word. Okay, Gargadi. So what I told you that the tension will be what? Two different tensions, T1 and T over here. T and T2. And what? As I said, same thing. If strings changes, tension changes over here. Since this whole string is same, the tension over is T, the tension over is T. Yes or no? Okay, you can't do that. The tension can be at this point of consideration. T, over here it is T, over here it is T, over here it is T. Only the direction changes. Yes or no? Depending on the point of consideration. And what? Third one is most of the time the string is considered to be massless A and what? Frictionless student. Is it good? अभी मैंने बोला उसके बारे में. Yes? Is it good? पानी भी लेता हूँ थोड़ा. Nice. Okay. Then what we talked about pulley problem also. Here we didn't solve the pulley problems. We were talking about in pulley problem. We talked about what? Tension. Basically, we talked about direction of tension. Yes or no? Direction of tension. Where we also consider that in most of the pulley problems, the pulley is considered to be what? Massless and what? Frictionless. This also you should remember. So do you remember the tension, the direction of tensions that we calculated over here? Over here it was what? T. Over here it was what? T. Over here it was what? T. Yes or no? Because, okay, just a second. Yes or no, students? Why? See, over here, you know that there is a weight M into G, sorry, MC into G, MA into G, and what? M B into G. Yes or no, students? And you know that due to this pulling force of what? Of the weight, there's a tension created. But for that, we need to like consider the point of consideration. Over here, this is a point, this is the tension. If this is a point over here, this is the direction of tension. And if this is a point, this is the direction of tension. Since the string is same. Yeah. Yes, sweetie. Obviously, right? Yes or no? Because you need to specify the tension. And for that tension, there will be a magnitude also. Yeah. Yes. And also, if you consider this point, where will the tension, students? The tension will be over here. Yes or no? And over here, what will happen? The tension will be along this direction, and along this, it will be this direction. Yes or no? Now, as I said, students, since we are considering this point, and this is a separate, this is a separate string, that is string number 2. What will happen to tension? Tension will be T2. Yes. Is there any doubt till now about tension? Let me know, students. Till now, is it clear how to take the direction of the tension? Is it clear? Let me know in the chat. Okay, nice, Abhay. Others. Janvi, okay, very nice. Pretty, very good. Aniket, very good. Ballari and Bagalkot students, North Canada students. Okay, Bagalkot students, very good. Clear path, very nice. Okay, good. Okay, just a second. If everything is clear, then here is a question for you guys. Okay, so I'm giving you 2 minutes of time. Let's say every student has to try it. Okay, I'll give you 2 minutes of a time to solve this. You need to draw the tensions acting on this body, on the whole body. Okay, I want you to draw the tensions over here. Okay, so I'm launching let's say the timer over here. There's a timer over here. I'm launching for 2 minutes. Okay, the time is running, students. So please draw the tension. And then what will I do is I'll also draw the tension. You need to cross verify. And after that, let me know how many of you have done the question rightly. Okay, it's good. Okay, please draw the tension, students. Please draw the tensions. बिना टेंशन के टेंशन ड्रॉ करो, आराम से ड्रॉ करो. अगर हो गया तो लेट मी नो इन द चैट की हो गया. अगर नहीं हुआ तो लेट मी नो. ओके, ಎಲ್ಲರೂ ಮಾಡಿ. Okay. Very good, Abhay. So, Jain students, all try ಮಾಡಿ, okay na? And Bagalkot students, please remove your tick mark. So there is no confusion. Very nice. हो गया. Okay, Par. Very good. Very nice. अभी भी टाइम है ना? बाकी बच्चों को अनिकेत very nice. 50 seconds more है. Sweetie very nice. Jainvi students, let me know. Ballari, North students, Madhya, let me know. Danagere students, Sushma, Priya. Okay, very good. Last 20 seconds, students. So don't worry if you're not able to do it. Don't worry about it at all. I'll explain you how to do it. Okay. Last 10 seconds. Last 10 seconds, students. Okay, 4, 3, 2, and it's 1. Okay, time's up. So I hope most of you have tried it, and it's okay if you're not able to answer it also. Let's take from point A. Okay. Now, students, always remember that if something like this given, then it is always same string, one string at all. Okay. This is whole is one string. This one. Okay. Now, coming into this point B over here, this is another string. Yes or no? This is the second string, and this will be what? This will be your third string. So, how many strings are there? How many strings are there? 3. If that is the case, very good. Then you got the idea that there will be what? T1 and T2. Total 3 tensions will be there. Yes or no? Now we'll talk about, see over here, if this is the, let's say, block of mass A, then there will be a weight acting downwards. That will be what? MAG. And also there will be a what weight acting for B? It will be what? MV into G. Okay, is it good? Now, students, now you know that if a weight is acting downwards, then there is, see, obviously it won't go down. There will be tension. Let's say at this point A, you know that what tension is always away from the point of consideration. It's away. बहुत दूर ही जाएगा ना. दूर, like तुम्हें दूर नहीं रहते. How the students? Yes or no? So over here, the tension would be what? Over here. Yes or no? Similarly, if you consider, yes, very nice. Consider this point what? It will be away from the point of consideration. It will be over here. If you consider this point, it will be away. If you consider this point, it will be away from the point of consideration. And if you consider this point, it will be away from the point of consideration. Okay, is it good? Now, students, since I told this is this whole string, see, follow my mark. This, and this is whole one string. The tension would be what? T, 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 and what? Okay, over here. These are the tensions. Yes or no, students? Yes? Very nice. Now, coming into the second string over here. If this is the point of consideration, what will happen? There will be a tension over here. And if this is the point of consideration, there will be a tension over here. And this tension can be called as what? T1 over here. And this also T1, because this is another string. Yes or no, students? Similarly, if I'm considering this point, then there is a tension over here, and this is what? T2. And if I'm considering this point, there is a tension T2 over here, which will be in the opposite direction. Yes or no? Yes or no, students? And if I'm considering this point, there will be a tension in this direction, and it will be T. Yeah. So all of you, please let me know, is your answer correct till now? Very nice. Very good. Very good. Very good. Yes. Okay. So if that is the case, students, see, you'd be wondering why this direction of tension is required. Today there will be a problem based on what FBD. Okay. So based on FBD, we'll have a problem where this tension direction is much more required. Then you will be knowing why I told you that we'll be talking about tension first, then we'll be going into what? The Newton's second law of motion. Is it good? And already you have studied about Newton's first law of motion. Is it good, students? Now coming into free body diagrams. Okay, what is this free body diagram? And let's say what is the importance of it? Okay, now you know that. Let's take a body. Okay, let's take a body. There is a body of mass m. Now you want to know first thing is what are the forces acting on it? Okay, what are the forces acting on this body? If the forces are acting on this body, then you want to know how are they acting? How are they acting? Okay, if you come to know how are they acting, then you want to know how many are acting. Okay, how many forces are acting on this body? Forces are acting. You want to know this is okay. So for that reason, you need something called free body diagrams. Okay, is it good now? So how many are acting? How are they acting? And what are the forces acting? You want to know that. So this will help you. What help you to solve numericals much more easier to solve numericals. Okay. So if you are able to do FBD, okay, what is it? Free body diagram. Then you will be able to solve numericals much more easier. Okay, much more in a easier way. Is it good, students? Okay. Okay, nice. I thought there is a doubt over here. Okay, very good. Now, when you're talking about free body diagram, there are certain assumptions based on what free body diagrams. Okay, see, if you want to do something, there are, let's say, if you're a researcher, you basically do that. You tell that, okay, these are my assumptions. These assumptions need not be followed by you, but what? But you need to what? You need to, in order to understand the concept of free body diagram, you need to understand the assumptions based on it. Okay, see, the first assumption over here is body is assumed to be a point mass. Okay, the body that is being considered is to be what? To be assumed as a point mass. What does it mean? Let's say, for example, we have a body of mass m. Now, students, what you need to do is you need to consider this body as what? Point mass body, and this should be the point mass m. Did you get it now? The first assumption. First assumption, pata chala na? Huh? Is it good? Very good. Now, the second assumption. We will show all the forces acting on the body, students. What? On the body. Please remember this sentence very, very, very carefully. This is an important point. अगर ये मिस हो गया तो आपका पूरा का पूरा एफबीडी मिस हो जाएगा. देखो, ये वाला ऑब्जेक्ट देख लो. इसमें एक वेट नीचे तरफ एक्ट होगा. yes or no? Weight is equal to m into g. Yes or no? And yesterday I said that if weight is acting downwards, then due to the surface, there will be a normal force acting on the body. Yes, normal force acting on the body. Just a second. There will be a what? Normal force acting on the body. Yes or no? And I called it what? Normal of what? Surface acting on the body. And also I told that since what? Normal force is a action reaction pair, there will be a what? There will be a normal force object will be acting on the surface, NOS. Yes or no? Now, students, since we are considering the body, then when you're considering the what FBD of the diagram of the free body diagram of the body of mass m, then you need to consider these many forces. Okay, what are the forces? One is what? Weight is acting on the body, and what? The normal force that is acting on the body, students. Here, if you write that there will be another force that is what? Normal force acting, that is NOS, then your answer will be wrong. Why, students? Tell me why. Why will be your answer wrong if you write NOS? NOS, why? Why? Because we want forces acting on the body. अगर एक forces body के ऊपर हो रहा है ना, वो हमें चाहिए. हमें वो forces नहीं चाहिए जो body act कर रहा है. ये देखो, ये जो normal force है NOS, I'll write it very neatly. How the students? ಈ NOS ಉಂಟಲ್ಲ, NOS, just a second, I'll write it very nicely. NOS ಎಂತ ಆಗ್ತಿದೆ ಇದು? ಇದು ಬಾಡಿ is acting on the surface. ಹೌದಾ? ನಮಗೆ ಎಂತ ಬೇಕು? ನಮಗೆ forces acting on the body ಬೇಕು, by the body ಅಲ್ಲ. Is it clear now, students? Everyone, let me know. Yes, so don't miss this point. Okay, very good Sweetie, very good Aniket. Yes, very good. Okay Sushma, very nice. Others JNV students? Okay, nice. The third thing is frame of reference should be ground or inertial frame. Okay, don't worry about the frame of reference. Okay, what is this frame of reference and all? We will be talking about in a different session about it. Okay, I'll clearly explain what is frame of reference, but consider this as what see, right now we are considering what this is as earth surfaces. So no, here whatever we try to do or the problems we are trying to solve is based on what? Ground itself. Okay, and this reference frame is also called inertial frame of reference, students. It's also called what? Inertial frame of reference. Okay, see students, always remember Newton's law holds only for what? Inertial frame of references only, students. Okay, it doesn't like it. There is something called non-inertial frame also. Here, see, we have to make sure that what we do is we what? Forcefully what? Let's say make sure that forcefully make Newton's law hold by introducing what? Pseudo forces, students. Pseudo forces. आप लोगों ने ये सुना है? सेंट्रीफ्यूगल फोर्सेस सुना है कभी? सेंट्रीफ्यूगल सुना है, students? Let me know, students. Or have you gone through Coriolis forces? So these are the pseudo forces, students. Okay, don't worry. We'll be talking about these forces in coming class. So what? See, just remember that when you are applying the free body diagram, okay, frame of reference should be what? Ground. Yes or no? Let's say if I'm keeping this body over here that is kept, this is what? This is ground. We consider it to be ground. Yes or no? So what you do is you call this ground to be what? Inertial frame also. And Newton's law hold only for inertial frames. And as I said, there is something called non-inertial frame. Don't worry, we'll be talking about it. What is inertial? What is non-inertial? But know the difference. Okay, the difference is in non-inertial force we need to forcefully make sure that the Newton's laws hold. But how do we do that? We introduce something called pseudo forces, okay, which doesn't exist actually, but क्या बोलते हैं उसको? मनगहा produce. You make it what? Make that forces up. Okay, you make it. Okay, I don't know the exact Hindi word about it. Okay, so those forces are like centrifugal, Coriolis forces. Is it good? Yes, students, is it clear now? So these three are the assumptions are made when you are considering what? Free body diagram. And there is something called note over here. What is this note say? See, as I said now, Newton's first law is not true in all reference frames. Okay, but we consider reference frame in which it is true. Okay, Newton's first law will not hold in all reference frame. Okay, such special frames are called what? Inertial frames. Is it good? Students? Those reference frames are called inertial frames. And we okay, Sushma, very good, very nice. Okay, and those inertial, see, we consider earth to be what? Inertial frame 2. We consider earth to be inertial frame 2. Is it good now? Is it good, students? अब पता चला ना कि assumptions क्या है इसमें? Let me know in the chat. Is it clear? See, I'm telling you the second point, student. The second point, what? The forces acting on the body. पता चल रहा है ना? On the body. मेरे ऊपर, on the body. Is it good? Okay. See, I'm focusing on it because I know he'll make the mistake. Okay, I know he'll make the mistake. Is it good? अगर ये सब गुड़ा है, then let us try to what draw the free body diagram. How to draw a free body diagram. ठीक है ना? अभी देखो क्या क्या है, आप सबको पता है. पहला assumption क्या करना है आपको, एक मिनट को. ओके, मैं इसको assumptions यही लिखा हूं क्योंकि आपको पता होनी चाहिए कि आप क्या कर रहे हो. ठीक है, पहली बात तो बॉडी इज assumed to be a point mass. इसको मैं पॉइंट मास मारूंगा. ठीक है, उससे पहले लेट अस डू वन थिंग. आपको पता है कि एक वेट एक्ट करेगा W is equal to M into G. Yes or no? And due to this weight there is, okay, this the weight, there is a normal. What is it? Normal due to the surface on the mass, and there is another force that is what? Normal on the what surface, sorry, on the surface by the object. Yes or no? That is by the mass on the surface. Yes or no? Now when you draw the free FBD, when you draw the FBD, what you do is you draw the FBD over here, that is mass M. And what are the forces now? I have just done it. What are the forces, students? It is what? One is weight is equal to M into G, and another is what? Normal force, that is NSM. अब हम ये वाला फोर्स कंसिडर नहीं करेंगे स्टूडेंट्स. ಹೌದಲ್ಲ ಹೌದಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸ್? ಯಾಕೆ ಹೇಳಿ? ಅದು ಆಬ್ಜೆಕ್ಟ್ ಸರ್ಫೇಸ್ ಮೇಲೆ ಅಪ್ಲೈ ಆಗ್ತಿದೆ. ನಮಗೆ ಎಂತ ಬೇಕು? ಫೋರ್ಸಸ್ ಆನ್ ದಿ ಬಾಡಿ ವೇಟ್. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಕ್ಲಿಯರ್ ಆಯ್ತಲ್ಲ? ಐ ಆಮ್ ಗೋಯಿಂಗ್ ವೆರಿ ಸ್ಲೋ because I want to make sure that everyone understood. Okay, everyone understands it. Very nice. Okay, if that is the case, students, please draw the FBD of this. Okay, I'm giving you 1 minute of time. Please draw the FBD of this pulley. Pulley ka FBD ek bar karo. Here is mass M2, M1, and there is a pulley. Please draw the FBD. Try solving it. Try solving it. Then I'll solve it. Try solving the FBD, students. Abhay, very nice. Very good. लेकिन एक और चीज आप मिस कर रहे हो. ओवर, वेरी गुड अनिकेत. Okay, Yuvraj, nice. Good evening. Sorry, Srinivas, good evening. Chaudhary, Ayushi, good evening. So I hope you are still in the class. Okay. This is for YouTube live students. Good evening. Okay, over. Very good. Very nice. Okay, if everything is over, then I'm going to draw the what FBD diagram. Okay. First of all, see over here. Let us draw the what are the forces that are acting. One is W is equal to M into G, M2 into G, and there is what? There is W is equal to M1 into G. There is weight acting, and you know that if weight is acting at this point, there is a tension acting. Yes or no? Yes or no, students? Now, when you draw the FBD, there is one mass that is M2, and there is this mass M1, and you know that there is one what? M2G is acting, and what? Tension is acting. Yes or no? Tension. And there is what? M1G, and what? There is another tension is acting. Yes or no? This is your FBD. But students, I know most of you have now done what? Pulley over here. Pulley को miss क्यों किया? पुली का भी FBD बनाओ ना. देखो पुली का क्या होगा? क्यों आप इसको कॉर्नर कर रहे हो? ये आपका पुली है. This is massless, obviously. Yes, it is massless and frictionless, students. For that reason, then what are the tensions over here and over here? Here would be the tension T, and here would be the tension T. Yes or no? Yes or no, students? And there will be a tension along this direction, that is T. What? T2. Is it good, students? And this will be the FBD of this whole pulley. FBD of pulley. पता चला कैसे करना है आप लोग? Is it good, students? Let me know. Nice. Janvi, Bagalkot. Okay, Yuvraj. Very nice. Is it from Bagalkot? Yuvraj, let me know. Okay, students, very good. If that is the case, then we'll try to solve the FBD of there are certain masses. Okay, over here this is already solved. Yes or no? This is already solved. इसको solve कर चुके हम, है कि नहीं? इसको solve करने की जरूरत नहीं है. अब जाएंगे इसमें. Okay, students, I'm giving you 2 minutes of time to draw the FBD. FBD draw करो इसका. देखो, एक मास m है बड़ा वाला और एक और है that is what छोटा वाला that is m and there is a force acting on this mass. बड़ा वाला जो मास है जो ऑब्जेक्ट है इसके ऊपर एक फोर्स लग रहा है. नाउ ड्रॉ द एफबीडी. एफबीडी को ड्रॉ करो एक बार. इसका क्या होगा फिर? वी ऑल्सो ड्रॉ डब्ल्यू. अबे आई डिडंट गेट यू. आपका रिप्लाई समझ नहीं आया. लेट मी नो. अबे सर वी ऑल्सो ड्रॉ डब्ल्यू. हाँ यस वेट यू मीन वेट. हाँ यस ये जो था ये क्या है? बेसिकली एक फोर्स है ना. ये भी एक फोर्स है ना. इट इज पुलिंग फोर्स. वो नीचे खींच रहा है तो एक फोर्स होगा बेसिकली. इसका इसका वैल्यू क्या होगा? फोर्स है ना वो, क्योंकि वो ग्रेविटी की वजह से नीचे भी आ रहा है ना. ये सब ठीक है इसलिए. हाँ अनिकेत वेरी गुड, वेरी नाइस. अबे ओके वेरी गुड, गॉट इट, वेरी नाइस. अदर्स लेट मी नो. Very good. Okay. So most of you done. Let me know from JNV, let's say Bagalkot, Ballari, North Canara, our students are able to do the FBD and all. Are they able to do it? Let me know please in the chat. On M force act on opposite direction of M. Okay, let us solve this. Okay, let us solve. See, over here, first we'll talk about the small mass. Okay, small mass m. Okay, first we'll talk about the small mass m. For this mass m, what will be acting? Let me know students, what are the masses that is acting? See over here, you know that there is one weight that is acting, m into g, and you know that for this there'll be a what? There'll be a, students, what? There'll be a normal reaction. Yes or no? That is what students? That normal reaction will be applied by which body? It will be applied by the what? This body. Yes or no? Yes or no students? अगर ये नीचे खींच रहा है तो ये सरफेस होगा ना. Let us say, just a second, can we consider this to be surface for this body? है कि नहीं? अगर एक weight नीचे हो रहा है m into g, तो एक normal will be applied by the what? Bigger mass to this smaller mass body. Yes or no? For that reason, this will be what? Bigger mass by the smaller mass. पता चला अभी? Yes or no students? Yes. Okay. Now talking about the bigger body. Okay, that is what? Mass m. Over here, see, you know that the force is applied for this body. Yes or no? Always remember students, if this force is applying on this, let's say over here in the diagram, students, see the diagram very carefully. Over here, the force is applying for this body. Yes or no? Here it is not applying. So the force will be acting. Force will be acting on M only. For that reason, students, the force F will be acted on the bigger mass body M. Okay. Now over here, yes. Now students, you know that, see, if this is mass m, there is a weight that is what? That is being applied. That is what? Weight is equal to m into g. That is bigger mass. Yes or no? Now students, see, over here, there is a surface. There is a different surface over here. Now if this surface, if the weight is going downwards, then this surface will act a what? Act a normal force. Normal reaction होगा. वो क्या होगा? सरफेस से होगा बॉडी पे. इज इट गुड? नाउ इज इट गुड स्टूडेंट्स? अब पता चला ना ये वाला और ये वाला कैसे एफबीडी बनाया हमने. अभी बहुत लोग ऐसे बोलेंगे, सर अगर ये एन एम एम है तो ये वाला बॉडी भी एक n what m अप्लाई करेगा ना, मतलब द बॉडी, दिस स्मॉल बॉडी विल apply a normal reaction or normal force on the bigger body. But students, as I said, we want what forces acting on the body. Okay, on the body. So if that is the case, students, what here there'll be another force acting on the body. That would be what? N, M, and M. Is it good? अब पता चला? Yes. Okay. Which should I repeat? Let me know. Let me know, students. See over here. Just a second. Okay, what is this happening? Wait. See, I'll draw it again. Okay, I'll draw it again. Over here, observe this. Okay, observe it. There is mass m and there is a surface. Yes or no? Yes, Aniket. Listen. First listen. देखो, मैंने बोला ये जो small body है, इसके ऊपर एक weight हो रहा है. Obviously, there is a weight acting downwards, and that we called it to be m into g. And for that weight, there is a normal force, the normal reaction that is acting, n, m, and m. And I told you that what there will be a what another force, since it acts as a what action reaction pair, there will be a force, and what the body, the smaller body will be acting upon the surface this body. Yes or no? Over here, see, ये एक्ट करेगा ना, अगर एक नॉर्मल फोर्स है बिकॉज ऑफ दिस बॉडी ऑन द स्मॉलर बॉडी, ये भी एक्ट करेगा ना स्मॉलर बॉडी से बिगर बॉडी पे होगा ना. लेकिन हम यहाँ शो न्यू फर्स्ट डायग्राम में व्हाई वी आर नॉट शोइंग इज बिकॉज वी वांट फोर्सेस एक्टिंग ऑन द बॉडी, नॉट बाय द बॉडी. लेकिन जब हम सेकेंड बॉडी कंसिडर कर रहे हैं ना, जब सेकेंड बॉडी कंसिडर कर रहे हैं, देखो ये वाला तो एक मिनट रुको, ये वाला तो सही है m इंटू जी, और इसकी वजह से एक नॉर्मल फोर्स है, ये भी सही है. दैट इज व्हाट, ये सरफेस है तो सरफेस की वजह से एक बॉडी के ऊपर एक नॉर्मल फोर्स है. बट अभी मैंने बोला एक क्या है, एक नॉर्मल फोर्स है बाय दी व्हाट स्मॉलर बॉडी, है कि नहीं. तो इसके लिए इसकी वजह से एक नॉर्मल फोर्स भी आएगा, दैट इज व्हाट बाय द स्मॉलर बॉडी ऑन द बिगर बॉडी. इज इट गुड? सो यहाँ कितने फोर्सेस है? 3 है. यहाँ कितने फोर्सेस है? 2 है. Force, okay, wait just a second, you might confuse after seeing the what the PDF. Forces are 3, forces are 2. अब पता चला क्या हो रहा है अभी? Let me know, students. Let me know. Bagalkot and Ballari students, let me know. M has four forces. Wait. Yes, sorry. Sweetie, very good for pointing it out. अभी मिस होने वाला था, एक और फोर्स है F, that is so 4 forces. Very good, sweetie. See, वही है, कभी कभी मिस हो जाता है ना, क्योंकि मैं एक्सप्लेन कर रहा था तो मैंने यहाँ तो लिखा है बट यहाँ मिस हो गया. Sweetie, very good. So how many forces are there? There are 4 forces. Is it good? YouTube live students, is it good? Sweetie? Yes, very nice. Very good. Abhay, let me know. Okay. Aniket clear हो गया ना अभी? हाँ, very nice. If that is the case, students, अगर ऐसा है तो ये वाला करो, ये वाला करो, जल्दी करो. ट्राई कर लो, ये भी सिंपल ही है, जो हमने प्रीवियस किया था ना उसी के ऊपर ही है. But remember, as I said, students, when a force is acting on a body, it will be acting on that force itself, like on that body itself. एक हिंट देता हूं मैं कि अगर फोर्स इसके ऊपर लग रहा है ना, तो बस इसके ऊपर ही लगेगा. Force is acting on this body itself. Force is acting on this body. That is what? Of mass m. It's not acting on mass m. Sir, but my question is that why we want to draw it? Abhi, okay. Why you want to draw the FBD, right? Aniket, very good. आप ये पूछ रहे हो ना FBD क्यों ड्रॉ करनी है? हाँ, ये ये चीज आपको जब लेट्स से प्रॉब्लम सॉल्व करोगे ना तब आपको पता चलेगा, ठीक है ना? इन वन प्रॉब्लम देयर विल बी यू नीड टू फाइंड टेंशंस एंड ऑल. अभी है फाइंड टेंशंस. जब टेंशन फाइंड आउट करना है ना आपको एफबीडी चाहिए, ठीक है? ये आपको जब न्यूमेरिकल्स ऑफ फर्स्ट लॉ ऑफ मोशन, न्यूटन्स फर्स्ट लॉ ऑफ मोशन, सेकंड लॉ ऑफ मोशन, ये सब जब करोगे तो आपको एफबीडी चाहिए, ठीक है? जब न्यूमेरिकल करेंगे तब पूरा पता चलेगा. ओके, so how do you draw the FBD of this? Okay, how do you draw the FBD of it? Now see, over here, yes, over here we have a mass. Let's say this छोटा वाला mass. इसके ऊपर ये एक surface के ऊपर है, yes or no? अगर ये surface के ऊपर है, there is a weight acting और एक force भी लग रहा है, force भी लग रहा है, yes or no? Now students remember, if this is acting, this weight is acting, there is a normal force that is acting by the surface, normal force acting by the surface on the body, yes or no? Now also remember there is another block of mass m, yes or no? Now students, this block of m will apply a normal force on this body. क्यों लगेगा मैं बताता हूँ. एक नॉर्मल फोर्स क्यों लगेगा? लेट्स टेक, वीडियो दिख रहा है ना? एक मिनट रुको. हाँ, जैसे मान लो ये वाला है, ठीक है? ये वाला है, ये मेरे पास है बॉडी, ठीक है? अभी ये इसमें रखा, अगर मैं इस पे फोर्स लग रहा हूँ तो इसी के ऊपर ही फोर्स लगेगा ऑब्वियसली, राइट? अगर मैं इसको ऐसे पुश करने की कोशिश कर रहा हूँ, इसको यहाँ से इस डायरेक्शन से फोर्स लगा रहा हूँ, तो ये वाला तो रेसिस्ट करेगा ना, ये वाला रेसिस्ट करेगा, है कि नहीं? और ये सरफेस है, ये वाला सरफेस है, तो उसके परपेंडिकुलर एक नॉर्मल फोर्स लगेगा ना, क्योंकि वो क्या करेगा? इट विल ट्राई टू रेसिस्ट इट, ऐसा नो? तो इसके लिए क्या होगा? ये जो नॉर्मल फोर्स है, दिस इज एक्टिंग बाय द बिगर बॉडी ऑन द स्मॉलर बॉडी, यस और नो? ये क्लियर है ये वाला? अभी जो हम एक और कर रहे हैं, जो बड़ा वाला बॉडी है, यस वेरी गुड. अच्छा ठीक है, देखो अनिकेत, ये वाला फोर्स क्लियर है, ये वाला फोर्स एक क्लियर है, ये वाला वेट क्लियर है, लेट मी नो अनिकेत, और ये वाला क्लियर है एनएसएम, है कि नहीं? लेट मी नो अनिकेत, yes or no? अनिकेत लेट मी नो. यस वेरी गुड वेरी गुड. अगर ये सब है तो मुझे ये बताओ, जब हम एक बॉडी को पुश करना चाहते हैं तो एक रेसिस्टेंट फोर्स तो आएगा ना, आएगा ना? देखो एक रिएक्शन फोर्स तो आएगा ना, ऐसा नो? अगर मैं इसको ऐसा पुश करना चाहता हूँ तो एक तो कुछ ऐसा रेसिस्टेंस तो होगा ना, थोड़ा तो होगा ना, एक नॉर्मल फोर्स तो होगा ना. तो इसकी वजह से ये वाला जो नॉर्मल फोर्स है, दिस इज एक्टेड बाय द मास m on what smaller mass m. और ये वाला होगा वो परपेंडिकुलर टू द सरफेस होगा ना, क्योंकि वो सरफेस है, जैसे ये वाला सरफेस था, अब ये वाला सरफेस है, ये वाला सरफेस है, तो नॉर्मल तो परपेंडिकुलर ही होगा ना हर टाइम. इज इट गुड नाउ? इज इट गुड? यस वेरी गुड. हाँ, अगर ये वाला मास हम ले रहे हैं तो आपको पता है, एक मिनट रुको, ये वाला हम इधर ड्रॉ करते हैं, ठीक है? ये वाला इधर ड्रॉ कर लेते हैं. ये मास m है, ठीक है? ये वाला सरफेस है, ये वाला सरफेस है. You know that there is a weight acting, W is equal to m into g, and there is a normal force acting, that is what? By the surface on the body m. Now students, now I told you that if there is a normal force, as I said, if there is a normal force acting by this, let's say mass m, bigger mass m on the smaller body, then there should be a normal force acting by the small m on the bigger mass, yes or no? Because it's a action reaction pair, है कि नहीं? हाँ, yes or no? Yes or no students? Is it clear? Yes, Harish, very good. So then there will be what? A normal reaction that will be acting on the what? On this body by the smaller body. अब पता चला? इज इट गुड? यहाँ आपको ये वाला फोर्स एक्ट नहीं करेगा, क्योंकि वो एक्ट कर रहा है, सिर्फ क्या, ये स्मॉलर बॉडी के ऊपर। जैसे yes, okay, sorry for the interruption. So what was happening over here? Here जो एक small body है, small body will what, apply this force. Is it good? Clear abhi tak? Let me know, students, and let me know others from other, let's say, JNVs. Let me know. Aniket, very good. Sweetie, nice. Madhya, very good. Bulk code, Badari students, North Canada students, crystal clear. Okay, very good, very nice. हाँ, अब हमने फ्री बॉडी डायग्राम बातें की या टेंशन बातें किया, ठीक है ना? अब हम बातें करेंगे क्या, इक्विलिब्रियम के बारे में. व्हाट इज दिस इक्विलिब्रियम? ओके, सो एवरीवन हैज स्टडीड न्यूटन्स फर्स्ट लॉ. न्यूटन्स फर्स्ट लॉ आपने क्या पढ़ा है ना? फर्स्ट लॉ, यस, हाँ, सबने पढ़ा है. तो उसमें क्या होता है आपको पता है कि यस, let's say in a very simple words, the body will be in that state itself. Let's say if it is in motion, what, it will be in motion, and if it is at rest, it will be at rest unless an external force is applied or an unbalanced force is applied. इसका मतलब क्या है? अगर मेरा एक बॉडी है, अगर इसको मुझे क्या, अगर ये बॉडी रेस्ट पे है, इसका मतलब क्या है? अगर मैंने इसको फोर्स लगाया एक, अगर मैं इसको लेट्स से, अगर मैं इसको लेट्स से मूव करना स्टॉप करूं, बिकॉज दिस इज एक्सटर्नल फोर्स, देन आई कैन अप्लाई अनदर फोर्स. यस और नो? यस और नो स्टूडेंट्स? अगर इसको मुझे स्टॉप करना है कि नहीं? तो इसका मतलब क्या हो गया? इसका मतलब जो नेट फोर्स है वो तो जीरो है ना. जो नेट फोर्स है वो जीरो है. वो कैसे आ गया? क्योंकि एफ नेट इज इक्वल टू एफ माइनस एफ विच इज इक्वल टू जीरो. जो ये वाला फोर्स है इसका मैग्नीट्यूड सेम है ना, इसका और इसका मैग्नीट्यूड सेम है कि नहीं? सो फॉर दैट रीजन इट कम्स टू व्हाट, इट रेस्ट. इफ एफ नेट इज जीरो, इसका मतलब क्या है? इसका मतलब एक और है ना कि एक्सेलरेशन जीरो है ना, है कि नहीं? है कि नहीं? yes or no? Now students, if acceleration is zero, I want to ask one question. इसका मतलब कि बॉडी हर टाइम रेस्ट पे रहता है या लेट्स से यूनिफॉर्म वेलोसिटी में भी रहता है? एक्सेलरेशन जीरो का मतलब क्या है? देखो, एक्सेलरेशन क्या है? dv by dt होगा ना, dv by dt होगा ऑब्वियसली. इसका मतलब क्या है? अगर v कांस्टेंट है तब भी एक्सेलरेशन जीरो होगा. तो बॉडी आइदर रेस्ट पे है, इट विल बी एट रेस्ट. अनिकेत, नो, अगर रेस्ट पे है, बॉडी एट रेस्ट पे है, अनिकेत लिसन, अगर रेस्ट पे है तो v इज इक्वल टू जीरो, तो आपका एक्सेलरेशन जीरो आएगा. लेकिन अगर यूनिफॉर्म, अगर यूनिफॉर्म वेलोसिटी पे है, यूनिफॉर्म वेलोसिटी का मतलब क्या है? कि वेलोसिटी चेंज नहीं हो रहा है. यस जीवन, वेरी गुड. रेट ऑफ चेंज ऑफ वेलोसिटी इन टाइम, वेरी नाइस. अगर वेलोसिटी वो कांस्टेंट है ना, अगर आप एक कांस्टेंट को डिराइव कर रहे हो, मतलब डिफरेंशिएट करो, डीवी बाई डी को डिफरेंशिएट करोगे तो जीरो होगा ना. इज इट गुड? अनिकेत, डिड यू गेट इट? अगर आप एक वेलोसिटी इज इक्वल टू 5 मीटर पर सेकंड है, ये कांस्टेंट है, अगर इसको डीवी बाई डी करोगे तो जीरो आएगा ना. तो इसका मतलब क्या है कि एक्सेलरेशन जीरो का मतलब कि वो सिर्फ रेस्ट पे नहीं है, वो यूनिफॉर्म वेलोसिटी पे भी जा रहा होगा. ಹೌದಲ್ಲ ಸ್ಟೂಡೆಂಟ್ಸ್? ಹೌದಲ್ಲ? ಹಾ, ಈಗ ಎಲ್ರು ಕೇಳಿ. ಈಗ ಬಾಡಿ ನಿಮಗೆ ಗೊತ್ತಿದೆ ಎಂತ, ನ್ಯೂಟನ್ಸ್ ಫಸ್ಟ್ ಲಾ ಏನ್ ಹೇಳ್ತದೆ? ದಿ ಬಾಡಿ ವಿಲ್ ರಿಮೇನ್ ಅಟ್ ರೆಸ್ಟ್ ಆರ್ ಇಟ್ ವಿಲ್ ಕಂಟಿನ್ಯೂ ಟು ಮೂವ್ unless and until there is external force. ಹೌದಾ? ಈಗ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಈಗ ಲೈಕ್ ಇರದಿದ್ರೆ ವಾಟ್ ಯು ಮೀನ್? ದಿ ಎಫ್ ನೆಟ್ ಇಸ್ ಜೀರೋ. ಎಫ್ ನೆಟ್ ಅಂದ್ರೆ ಜೀರೋ ಅಂದ್ರೆ ಎಂತ? ಆಕ್ಸಲರೇಷನ್ ಜೀರೋ. ಹೌದಾ? ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಆಕ್ಸಲರೇಷನ್ ಜೀರೋ ಅಂದ್ರೆ ಎಂತ ಅರ್ಥ ಆಗ್ಬೇಕು? ಒಂದು ರೆಸ್ಟ್ ಅಲ್ಲಿ ಇರ್ಬೇಕು, ಬರೀ ರೆಸ್ಟ್ ಅಲ್ಲ ಆಯ್ತಾ. It will be it can be in uniform motion also, that is uniform velocity also. Is it good? Now coming into equilibrium, when you coming to equilibrium, it means that what? It means that what? F net, in a simple words, F net is 0. Andre, the total force acting is 0. Okay na? Okay ಅಲ್ವಾ? ಈಗ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋ. ಈಗ ಮಾಸ್ ಆಫ್ ಬಾಡಿ m ಉಂಟು. ಓಕೆನಾ? ಇಲ್ಲೊಂದು ಮಾಸ್ ಆಫ್ ಬಾಡಿ m. Is it good? Mass of body m ಉಂಟು. Is it clear? Let me know. ಈಗ ನಾನೀಗ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿಂದ F ಅಪ್ಲೈ ಮಾಡಿದೆ and ಇಲ್ಲಿಂದ F ಅಪ್ಲೈ ಮಾಡಿದೆ. If I apply the force F, so what do you mean? F net equal to 0. Yes or no? That means acceleration 0. Yes or no, students? Let me know. Let me know quickly. Very good. Now, okay. Let me take this direction x. Okay, this is as my direction as x. If that is the case, can I say in x direction, the sum of forces is equal to 0? Can I say this? If I'm taking this as the x direction, obviously, right, the sum of forces is 0. Yes? Can I say this? Very good. Similarly, let's take this, the mass, same mass m. Okay, I told you that there is a force acting over here, there is a force acting over here, F and F. Okay, there's a force acting. Okay, now if it is acting, you know that there is a normal force, there is weight acting, this is mg, and there is a normal force acting. That is what? Normal force by the surface on the object. Now students, if I take this as my y direction, ये बताओ ये बॉडी ऊपर जा रहा है क्या? ये सरफेस ऊपर जा रहा है क्या? नहीं ना. अगर मैंने ऐसे अप्लाई करूं तो यही रहेगा ना, ऊपर तो नहीं जाएगा. Yes or no? So if that is the reason, can I say F forces on y direction is equal to 0? Okay, is it good now? So when you say equilibrium, you need to say that forces on every direction must be 0. इसका मतलब क्या है? इसका मतलब forces acting on what? X direction should be 0. Force acting, the total force acting on y direction should be 0, and the total force acting on z direction should be 0. Is it good, students? जो equilibrium का जो simple word है ये बोलता है वो, बस पता चला? Let me know, students. Others, let me know. Ballari, Jeevan, let me know. Ballari students, Canada students. Aniket, very nice. Others? Okay. Madhya, very good. Okay. Ha. Yes. Okay. The total, in balance forces, the total, see, over here in the balance force, it takes, let's say, in one direction, let's say x direction. But here, when you say equilibrium, you need to tell that from every direction. Let's say this is, okay, this is x, this is y, let's say the z direction भी है. सारे direction में the forces are what? 0. Is it good? Now, coming into the definition of it, when you talk about the definition of it, मैंने simple words में बोला, it says that the equilibrium of a particle of a system refers to the situation when the net external force, that is what? Net external force is what? On the particle or the system is 0. So it means what, students? I'll write it again. F net equal to 0. It means what? The x direction force, sum of x direction force, sum of y direction force, and the sum of z direction force should be 0. Is it good? Is it good, students? Clear? Yes, very nice. Others, let me know. Okay. So actually I had a problem to solve. Okay, since we have very limited time, what I want you to do is, see, consider this problem. Okay, try solving this. Try solving. Don't worry, I'll be solving this in the next class. Okay, here, see, consider the body to be in equilibrium. Okay. Okay, and what? String to be massless, and what? Frictionless. Now students, what you need to do is, you need to apply where the tensions are working. Okay, here you know that this is string 1, and this is string 2. Okay, now after applying everything over here, there is, it makes angle 53 degree. I'll give a hint, students. This is a famous 53-degree triangle. If this is 53, let me know, students, what is the angle over here? What is the side? 53 degree में ये वाला side क्या होता है? Let me know, students. ये वाला side क्या होता है? अबे, it's okay. Very good. This side will be 3. This side will be 4. Okay. There is another triangle. That is what? 37 degrees. See, you should remember this. Okay, 37 degree. That is what? 5. It will be 4, and this will be 3. Is it good? So I want you to try this problem over here. You need to what? You need to find the tension. Like basically tension का value क्या आता है और tension 2 का value क्या आता है? You need to try it. I'll solve this problem. I'll give a hint. Okay, you need to what? Let's say extend this, and this will be always, this will be also be what? 53 degree. क्योंकि क्या है, ये z होता है ना, आपको पता है ना कि अगर कुछ z लिखा है ऐसा, सॉरी, और आपके पास ऐसा कुछ है जो ये थीटा होगा ना, वो भी ये थीटा होगा ना. अल्टरनेट ट्रायंगल्स. यस, वेरी गुड, वेरी नाइस. हाँ, तो आपको ये ट्राई करो सॉल्व करने के लिए. ठीक है, so in the next class I'll be solving this. Okay, in the next class. But if you're able to solve this, very good. Okay, very good. So that's all for today, students. So in the before ending today's session, let me quickly go to the summary of today's session. Also, I'm launching the NPS poll. Let me know to the NPS how was my class and what are the areas I need to improve, or if you have any feedback, please try giving me. Okay, since see, this is an online class and it's very difficult to have a very fruitful interaction. Yes or no? This is for every students who are present here. For YouTube live students, let's say for Harish, very good. For let's say JNV students, so it's a very difficult task. So let me know how can I improve. If you want much more, let's say when the class proceeds, I can apply, let's say, simulations, or let's say more diagrammatical things if you need, or pictorial representation. Let me know. Okay, this would be very helpful. Yes, Aniket, thank you. So what and all did we do today, students? What did we do first? Let me know. We talked about free body diagram. Yes or no? Free body diagram. We came to know that how to draw. Okay. Abhay, we'll have a discussion about it separately. Okay. One day I'll talk about the books or the reference materials that you can observe. Okay. You can look into it. Is it good? I'll make a proper PDF or else a PPT so that you can have the screenshot of it. Okay. So how can we draw the FBD? Yes or no? How can we draw the FBD? We also saw that. We also solved numericals based on it, solved problems based on it. And also we saw what? Equilibrium. What is equilibrium? And since we didn't have time, we see that how these tensions, this equilibrium will help us to solve numericals. Okay, is it good? Is it good, students? Okay, so thank you for attending. Okay, take care. Bye-bye. See you in the next class. Thank you for attending YouTube live, students. Take care. Bye-bye.